This video is going to focus on factoring a polynomial function completely. So here we have an example where we want to completely factor this polynomial, x to the fourth minus 5x cubed plus 15x squared minus 45x plus 54. And earlier we looked at videos of calculating the zeros, and we can do the same thing here to actually help us factor the polynomial function. So there's not really a good way to factor this without finding some of the zeros. So my first step is I want to look at the graph of this polynomial function. So I'm going to type this into the calculator. And if we go to y equals, we have x to the fourth power minus 5x cubed plus 15x squared minus 45x plus 54. And I'm going to start with zoom and standard just to see what we come up with. All right, and we have our graph. It comes down and it goes back up. So from this, we can see here that it crosses the x-axis twice. So if I copy this, the part that we're concerned with is we realize that it crosses here in two places. So if we find these two values, we would have two of our zeros, which means we would have the factors. So if we look here closely, we can go to the calculator, go second, trace, number 2, we want to calculate the 0. So once again here, I'm going to set my left bound and our right bound, and then we can certainly guess. And we get a 0, x equals 2. So here we have x is equal to 2, and we can find the other one, second trace, 0. Again, we're going to set our left bound and then our right bound, and then we guess, and we get x equals 3. So here we have x equals 2, x equals 3. Now we know that from looking at this problem, we know that there should be a total of 4 zeros. That means that we have 2 real zeros, and most likely the other 2 are going to be complex. So we can take each of these zeros, and I'm going to use our synthetic division. So I'm going to start with 2 and bring down the coefficients. We have a 1, negative 5, 15, negative 45, and a 54. So we have x to the fourth, x cubed, x squared, x to the first, and then x to the 0. So if we bring down the coefficients, 1, negative 5, 15, negative 45, and a positive 54. Using synthetic division here, we're going to bring down the 1. 2 times 1 is 2. Negative 5 and 2 is a negative 3. So here we have a negative 6. 15 and negative 6 is positive 9. Times 2 is 18. Negative 45 and 18 would be a negative 27. Times the 2 is a negative 54. Now, at this point, we know from the calculator that x equals 2 is a 0. So this better come up with a remainder of 0. Otherwise, we've made a mistake either in our division or when we put the function into the calculator. So this has to be a remainder of 0 if x equals 2 is a 0. All right, now we want to continue to break this down. So this now was originally up here, x to the fourth. So that means that now our term here would be 1x to the third minus 3x squared plus 9x minus 27. So now if we take each one of those coefficients, and we can continue to use synthetic division, but now we're going to use the other 0, 3. So we're going to put a 3 out front, and we have a 1, negative 3, 9, and negative 27. Bring the 1 down. 3 times 1 is 3. And then we get 0, 0, 9 times 3 is 27. And again, that gives us a remainder of 0. So now here we have the coefficients. And again, here we started with x cubed. So that means here we're going to drop it down to an x squared. So we have 1x squared. And then we would have technically here plus a 0x plus 9. So that really means we have x squared plus 9. Well, this is now in something that we can actually factor, x squared plus 9. And if you're not able to factor this, we could probably look at this by finding the zeros. Now, if we set this thing equal to 0, we would end up with x squared equals a negative 9. And if we take the square root then of each piece, we would end up with x equals a positive or negative 3i, because the square root of 9 is 3, the square root of the negative comes out as our I. So from here, we know that we have our zeros we started with. We had from the calculator x equals 2, x equals 3, and then we came up with over here x equals 3i and x equals a negative 3i. So there we have our 4 zeros. 2 are real, 2 are complex. Now keep in mind, we're not looking for the zeros, we're trying to factor this polynomial. But if we know that x equals 2 is a 0, that means that x minus 2 is a factor. And if x equals 3 is a 0, that means x minus 3 is a factor. And then the same thing here, if x equals 3i, that means that x minus 3i is a factor, and then x plus 3i is also a factor because, again, they occur as conjugate pairs. So here we have completely factored our polynomial. So here's an example where if you're trying to factor, go to your calculator, graph the polynomial function, and you can find all of your real zeros. And then if you have any complex zeros, you can take your real zeros using synthetic division to break down your polynomial into something that you can actually find your complex zeros. All right, here we have another example. And once again, we're going to start out the same way. We want to start by graphing the polynomial function. So if we go to our calculator, we're going to type in the polynomial function here. So we have 4x to the 5th minus 8x to the 4th power minus 5x cubed plus 10x squared minus 2. And again, if I start with zoom standard, let's see, evidently I made a mistake here. Let's see. What did I type in wrong? We have 4x to the 5th minus 8x to the 4th minus 5x cubed and here I have 5x cubed and I have 2 plus signs here. So I need to delete one of those. So we have 10x squared, 5x cubed plus 10x squared, and this should be plus x. Oh, wait a second. 10x squared plus x, and then we would have a minus 2. So then if I go to zoom standard, and I'm going to zoom in a little bit. Our graph goes up, down, and it's a little tight inside here. So if we try to go to zoom number 2, which is zoom in, and I want to zoom in the origin, so I'm going to leave the cursor flashing here in the middle. So I'm going to simply hit enter, and it's going to zoom in right on this middle section. And that's what we're looking for. We want to find here where it crosses the x-axis. So if we copy this, and we can post this over here so we can look at this a little bit better. And notice we're concerned with, we have 1, 2, 3, 4, 5 places that it crosses the x-axis. So that means we're having 5 zeros, and over here our largest exponent is a 5. So that means our total number of zeros is going to be 5. So in this case, they're all going to be real zeros. So at this point, we could simply find the zeros using our calculator. And if we do that here, I'll start off with a couple of these. We would simply go second trace, number 2 for zeros. And again, you're going to set your left bound. And I won't do each one of these, but if we set the left bound, and then we go over here and we can set our right bound, and then we can guess, and this first one here turns out to be a -1. So this is equal to a -1. And again, we could go through and do the same thing for the other zeros, but I'm not going to take the time to do that. I've done that already, and I know that we end up here with x equals -1, and this one here turns out to be a -1/2, and this zero turns out to be a +1/2, and this next one turns out to be a 1, and the last one over here turns out to be a +2. So that means we have x equals -1, x equals a -1/2, x equals a +1/2, x equals 1, and x equals 2. So there we have all 5 of our zeros. Now keep in mind, we're wanting to factor, so that means that if x equals -1 is a 0, then that means x plus 1 is a factor. And then here, that means that we're going to multiply by x equals -1/2. We're going to multiply the 2 over, so that's 2x. And if that's 2x equals a -1, we need to add the 1. So that becomes 2x plus 1. And the same thing for x equals a half. You're going to multiply by 2, so you get 2x equals 1. But now you need to subtract the 1 over, so that becomes 2x minus 1. And then, of course, you get x minus 1 as a factor, and then x minus 2. So here we have completely factored our polynomial. And if you want to take the time, you can multiply this back out, and you would come up with the original function. So in this example, we didn't have to use the synthetic division like we did here, because all of our zeros turned out to be real zeros. So that means here all of the factors are real factors. We didn't have any complex factors as we did up here, x minus 3i and x plus 3i. So factoring can be really easy if you have all real zeros. All right, one more example. We want to factor this function completely. And once again, we're going to start the same way, simply by looking at the graph. Now, we know that we should have a total, if this is 3x cubed, our largest exponent is a 3, so we should have 3 zeros. So if we enter this into the calculator, go to y equals, we'll clear all this out, and we have 3x to the third power minus 4x squared plus 8x plus 8. And again, I'll go to zoom and standard. And it looks like here, we know that we have an x cubed. Our graph is going up through here, so we know that it's not going to come back down. And this is where, and let's see, I'm going to zoom in a little bit here. Zoom in. I'll zoom in right here on the origin a little bit. And knowing what we know about our functions, if I paste this over here for us, you may be thinking, well, how do we know that this function, how do you know this is the only zero? How do we know that this graph doesn't go up and then come back down so that we have another zero? Well, that's a possibility, but we know here that if we have this x cubed, it's a good chance that this may be the only one that we have because we know that our graph has to be going up and down. Now, if you play around with your window enough, you're going to find out that this graph is going to continuously here to go up. It's not going to come back down. All right, so we know that we need to find this particular 0. So if we go to the calculator, we can go second trace, number 2 is 0. We can set our left bound. See if we can find the cursor here. There it is. If we set our left bound and then we go over here to the right and we set our right bound and then we guess. And notice we get a negative 0.6 repeating. Okay, so that means that our 0 here is a negative 0.6 that's repeating. And a negative 0.6 that repeats is really going to be a negative 2/3. And that means that x equals a negative 2/3 is one of our zeros. Now, if that is one of our zeros, how do we find the others? Well, from this point, we could use our synthetic division. So that means we're going to take our negative 2/3 and then we would bring down the coefficients. We have a 3, a negative 4, positive 8, and another positive 8. All right, so then from here, we're going to bring the 3 down, and then we're going to take 3 times a negative 2/3, and that's going to give us a negative 2. Negative 4 and negative 2 is a negative 6, and we're going to take a negative 6 times a negative 2/3, and that's going to be a positive 4. So 8 and 4 is 12, and then we're going to take 12 times a negative 2/3, which equals a negative 8. And once again, we knew this had to be a remainder of 0 because our 2/3 is one of our zeros. So once again, up here we started with x cubed. We're going to drop that down 1, so our first term is going to be x squared. So that's going to be a 3x squared minus 6x and then a positive 12. So now hopefully this is something that we can factor. Well, let's see if we can do that. If we try to factor this, we may say, well, the only option here is 3x and x to get 3x squared. Now for the 12, you could go 1 and 12, 2 and 6, 3 and 4, and we know this is a positive, so both signs are going to have to be negative because this sign here is positive and this one is negative. So this says they're the same. The negative says they're both going to be negative. So what combination is going to give us 12 but then give us this negative 6? Well, 1 and 12 is not going to work because if you put a 1 here or 12 here, remember this number has to be multiplied by 3 and this number is multiplied here, so that's not going to give us the negative 6x that we need. And if we try 2 and 6, well, 6 and 3 is 18. 18 and 2 is not going to work. And if we switch it and make it 6 and 2, that's going to give us 6 and 6. That's not going to give you the negative 6. And if we try 3 and 4, that's going to give you 12x and 3x. So that's not going to work. And even if you switch it, I don't think that's going to work either. So we're going to get 9x and 4x, and that doesn't give us the negative 6. So it looks like we may not be able to factor this. And I just went through that to make a point. If this is the only 0 that we have up here, then what does that tell us about the 3x squared minus 6x plus 12? This is not going to give us a real solution. So this isn't something we're going to be able to easily factor. So here we could actually set this up and use our quadratic formula. So we could say x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So over here, x is going to be equal to, and here we have A is equal to 3, B is a negative 6, and C is equal to 12. So we have a negative B, so that's a negative 6 plus or minus the square root of negative 6 squared minus 4 times 3 times 12, and that's all divided by 2 times 3. So if we simplify this, two negatives make it a positive 6, and then we have 6 times 6 is 36, and then we have 4 times 3, which is 12, and 12 times 12, which is 144. 2 times 3 is 6. So 6 plus or minus the square root of 36 minus 144, that is equal to a negative 108. And let's see, is there any way that we can break down a negative 108? So in other words, if our first perfect square is 4, does 4, what is 108 divided by 4? Well, 108 divided by 4 is equal to 27. Let's see if we can have anything else. What about 108 divided by, or next would be what, 3 squared, which would be 9. So 108 divided by 9, that's equal to 12. So it looks like if 4 goes into 108, 27, and 108, 9 goes into 108, 12, then 4 times 9 is 36. So 108 divided by 36 is equal to 3. So it looks like we can use 36 times 3. So over here, if we think of this as 6 plus or minus the square root of a negative 36 times 3, then how can we simplify this square root? Then we would have 6 plus or minus. The square root of 36 is 6. The square root of the negative is I, and then the 3 remains underneath. And now we would have 6 over 6 plus or minus 6i square root of 3 over 6. And I just did this to show you that your 6's here are going to divide. So therefore, we're going to be left with 6 over 6 is 1 plus or minus 6 over here is divided to 1, so that's I square root of 3. Now, that is what x is equal to. So there's our 0. That means that x equals 1 plus I square root of 3, and x equals 1 minus I square root of 3. And we already said from above that x is also equal to, from the calculator, x is equal to a negative 2/3. So if we bring down the negative 2/3, there's our 3 zeros. Now remember, we're trying to factor, so that means the factors must be x minus 1 minus I square root of 3, x minus 1 plus I square root of 3, and then over here multiply by the 3, so that's a 3x, add the 2, so that becomes a positive 2, so we have 3x plus 2. So here we have completely factored the polynomial function. And once again, if you were to multiply the 3 factors out, you would come up with the original polynomial.